What's going on, you guys? This is Mr. O'Keefe, and I'm going to go over problem number 9 on the Integrated 2 Basic Skills Review Day 1. This is problem number 9 on systems of equations. So here we have two equations that are linear functions. One is orange and one is blue, and the question is asking for us to graph the system of equations and then state the solution to the system. So a system is working with multiple equations with the same variables at the same time, simultaneously. So here we have this equation, and I want to move the equation or get the equation adjusted so that it ends up in slope-intercept form, or some of you might call it y form, or so it looks like that, y equals mx plus b. So I need to unscramble it. To do that, I'm going to move this positive x to the other side of the equal sign by adding the opposite and eliminating the x on the left-hand side. That will leave me with y isolated or by itself, or closer to being by itself. So when I do that, this goes away. I bring this straight down, so I have this negative 2y equals, and instead of writing or combining these, I'm just going to write these two things out side by side. So it's still negative 4 combined with a negative x. I just wrote it side by side. The next step is to isolate y by dividing by the coefficient of y, or the number in front of y. So if I divide it with this term, I have to do the same thing for each term on the other side of the equal sign. By doing that, negative 2 divided by negative 2 gives me positive y. Negative 1x divided by 2 gives me positive 1 over 2x. Negative 4 divided by negative 2 is positive 2. So now I have created an equation in slope-intercept form, transformed it. Now I can graph that. To graph that, remember, in slope-intercept form, you want to start with the y-intercept, in this case, positive 2, 1, 2. So there's my y-intercept is at 0 on the x and 2 on the y. And I'm going to have a slope, which is the rise over the run. So I'm going to go up 1 and over 2. That's my slope, rise 1, run 2. Establish your slope triangle. And keep that pattern going until you can draw a graph, extend that graph, connect the dots. And that's the graph that represents the equation. And I think what I want to do is right here, I'm just going to draw a little slope triangle, rise of 1, run of 2, and that represents the slope right here. And we started at 0, 2. Same thing on this other one. Blue equation, I'm going to move the 2x by adding the opposite. I end up with negative y on the left-hand side. Remember, this goes away. Equals negative 2x combined with a positive 4. I want my x as the first term on the right-hand side here. Divide by negative 1. Remember that negative sign, you guys. Pay attention to those signs. And I have to do that for every single term. So that isolates this into y equals 2x minus 4. Now I've got this equation that I can graph in the same fashion. Go to negative 4, 1, 2, 3, 4. Put my starting point or my y-intercept, 0, negative 4. And then the slope is 2. Now this is a whole number, so remember it's over the denominator of 1. Now I have a rise and a run. A rise of 2, 1, 2 over 1. 1, 2 over 1. 1, 2, over 1, 1, 2, over 1, 1, 2, over 1, and then same thing the other direction, down 2, back 1, down 2, back 1, connect the dots. You have two linear equations or linear functions represented on the same graph. That's what makes it a system. The point of intersection of those two systems is the solution to the system. So in this case, I count over on my axis 1, 2, 3, 4, and then I count up 1, 2, 3, 4. So the point where these two lines cross is 4, 4. So the solution to the system is 4, 4, and the graph is represented visually for the two equations.